Right, now we can work on the Niagara fluids portion. So I will Control C on our sparks and Control V. And so these will be our missiles. Spawn rate, let's do 30 of them. And one thing we didn't do in the previous video is let's randomize the spring tightness, which will again just randomize how fast they're arriving in that center point. So random range between 1.5 and 2. And then we can add the set fluid source attributes as usual. And right click, add emitter, grid, 3D gas, add. I always like to just stop the timeline in here because it can get kind of laggy. Emitter summary, source, sphere source, turn it off. And then use emitter source to select it all and just type missiles. Click away. And for the size of the grid, I ended up doing 2750 by the same number by 600 on the Z with a resolution of 350 and 10 pressure solve iterations. We also need to enable temperature, and under render we need to set render temperature as black body. Alright, so we are getting something, not a bad start. We just need to improve how these trails look. First thing we need to do is increase the size of the particle that is emitting the smoke. I think right now it's too small, and that's why the trails are basically just dots. There's not enough smoke coming out. So for the radius of the particle, I'll do random range between 12 and 14. Nice, so that's giving us much thicker and more solid trails. Next is the velocity scale. So right now the smoke again is being given full speed from the particle that's emitting it, but if you want nice trails, you generally want to lower the velocity scale. So I'll just set that to half, so 0.5. So that got rid of some of that blobbiness and those dots, so we're starting to get some solid trails. We can move some of these lights in a better place so it's easier to see the smoke. And so the light that is surrounding her can have that magenta color because that's where the missiles are converging. So I think it already doesn't look too bad, a pretty cool effect, but the smoke lingers around for too long, and also we're still not seeing any fire. Let's increase the temperature to 2 and give it a divergence of 1 so that the fire expands a bit more after it's born, which means that under source we need to enable read divergence, don't forget. Nice, so now we have some fire, but we can color it pink just by going to the render tab, and here you have fire color. So let's also give it that magenta pinkish color. Nice, and let's kill the smoke sooner. So simulation dissipation rate density, let's try 0.6, and dissipation rate for the temperature set to 0 so we get some long fire trails. Nice, I'd say we're almost there. Let's add some turbulence to the smoke. So I will increase my resolution to 400 turbulence, and we've done this a few times at this point, so you know what to do. We just have to make the frequency just one number, so vector from float, set it to 0.01, set the speed to 1, and turbulence gain also vector from float. Let's try 400. Okay, so that's way too strong. So maybe just 100. Okay, not bad, but I think final number I will do 75. I'll do the same for turbulence too. So I'll just pause the video while I do this because you know what to do. So I'm doing 0.005, 1 for speed, and 30 for the gain. So they just add some very subtle, larger noise waves through the smoke. And finally, I want to make it look like the missiles are actually colliding with the force field more and have some of that fire spread across the force field. So the best solution I found after some back and forth was to actually just disable the kill particles in volume for the missiles. And instead we're going to have them collide with the force field. So I'll just add a collision module. And for the collision type, set the to distance fields. That worked better for me. And then we can just turn off the sprite renderer. And what we're left with are the smoke trails that actually collide with the force field, and the fire kind of lingers around her. So you can see the force field visually like this. Pretty cool. Okay, so this will be my final result. Definitely gonna leave it up to you to play with the lighting. Maybe add a cool camera move for your own shot, or game, or cinematic, or whatever it is that you're working on. So we covered some new modules, including the spring force, kill particles in volume. We created some nice trails, and you can use this for any kind of missiles, like a bazooka, rocket launcher missile, or anything like that. This technique applies to everything. So I hope that you enjoyed, and I'll see you in the next part. So I've made a new level 7 fire vortex, and I made this simple environment, basically the same that I used for the fire ring. So I just have these 3 Quixel rocks as the background, some trees on the ground. These are all from Quixel. You don't have to have these in the scene, right? The environment is up to you. And so we will use the Ring of Fire Niagara setup as the base for the fire vortex, so we don't have to redo everything from scratch. So VFX folder, NS Ring of Fire, Control D, call it NS_fire vortex, drop it in, reset the location to 0. And so this is a great starting point, right? We've already done a lot of work with the turbulence and all that. Now we just have to make it spin around. And I will show you how to control the size of it through sequencer and animate those shock waves and all that. So Control E to open. Spawn rate, let's set to 5000. Now for the lifetime, I did a minimum of 0.5. And then I want there to be that occasional burst of flames that lasts longer. So we're actually gonna randomize the maximum one more time. That's a little trick that you can do to basically force Niagara to give you even more randomized values. For the second minimum, I'll do 0.75, and the maximum I'll leave at 1. We can delete our mesh location, and instead I want a shape location because we need it to be a torus, right? So shape primitive, torus. The large radius, I did 250, and the handle radius, which is basically the thickness of the donut, 15. We can delete the gravity, and the flames just last way too long. So let's start working on the fluid source attributes. So density, I did 0.2, so just a little bit of smoke. And right now the divergence is way too high, so the flames just expand way too much. I want the minimum to be 0, and the maximum I want to randomize again. So random range between 1 and 4. This means that occasionally there will be like an explosive burst of flames with some of the particles. The radius we can randomize between 8 and 11, and the temperature between 1 and 1.2. Right, so much better already. We're starting to definitely get somewhere. We need to kill the smoke much faster. So dissipation rate density, I actually ended up doing 2, right? So don't forget you can go past 1, and this will kill the smoke very, very quickly. So it's barely there. And the dissipation for the fire, we need to randomize that as well. All of this randomization, it's a bit tedious, I know, but it really makes a difference for the final result. So it's worth it to do it for as many of the important values as you can. So I did between 0.4 and 0.6. The resolution I'll set to 350, and temperature buoyancy to 0. So the fire actually isn't rising as much, and it just remains in that vortex shape close to the ground. Now for the size of the grid, I did 2300 by 2300 by 400 and 0.4 on the z-axis. So if you look at it, you can see some really beautiful random behavior. The fire is not the same all around. We're getting some random bursts of flames. Now we just need to make it spin around. But first, So for turbulence 1, I will increase the turbulence speed to 2 and set the value from 400 to 600. So this way it's broken up even more. So now we can finally go under particle update and add our vortex force module. And I did a vortex amount of 1000, but the vortex force will make the particles basically overshoot a lot, and we need to keep them contained to the torus shape. So if you've ever followed my portal tutorial, you know that we need to add a drag, right? So this is how we will create those kind of shock waves coming from the circle. If you just reduce the vortex amount to maybe 400, you just get a nice little spinning fire ring. So this is a great start. If you're following along, that's awesome. I hope that you're looking at something similar. And in the next part, we will add some sparks and I will show you how to control the radius and strength from the sequencer using custom Niagara parameters.